Hi. Well, what we're going to look at is the sum or differences of cubes. But before we do that, I'd like to talk about last section, how we factored a difference of two squares. So now we're going to have a sum or a difference of cubes. So notice that the sum of two squares can usually not be factored. Okay, so the sum of two squares. The most that can be done is factoring out a common factor. In this section, we will learn how to factor the sum and differences of two cubes. So what this means is that before, if we only have two terms and we have something like this is a difference of two cubes, then we would factor this out. X times X, 2 times 2 gives you 4, and you have a plus or minus so that the middle term drops out. All right, that's how we factored those. If we had a sum of two cubes, all right, then for now, as far as factoring goes, we would call it prime. So we have a difference of two squares and a sum of two squares. And this one, we don't factor this one right here. We wait until we get into imaginary numbers in order to solve something like this. But a difference of two squares was possible. Well, when we have a difference of two cubes, we have formulas to follow in order to factor those. Either like x cubed minus, let's see, 8. Okay, this is a difference of two cubes, whereas this was a difference of two squares because something times itself gave you this, something times itself gave you this. This is a difference of cubes, so you're multiplying numbers, x times x times x. You've got 3 of them now that multiply together to give you this one, and 2 times 2 times 2 gives you that one. So we call this a difference of two cubes, and we'll just follow a formula. The thing is even though we could not do this one, we have a formula for this one. So these two are both possible. Whereas when you're given difference of two squares, you can't have a sum of two squares. So these are what we're going to look at today. And then we're going to review some factoring techniques, kind of review, just keep reviewing. All righty, so we're going to talk about those today. So let's go ahead and get started. All right, to begin with, we're going to multiply these together. And it's just kind of, it's a nice review of multiplying a binomial to a trinomial. It's been a while since chapter 5. So you can't use a FOIL, so you take A times everything, so you're still leading with an X. And then we'll take B times everything and we'll combine our similar terms. So we'll take A times A squared is A cubed, adding exponents. A times a minus AB is a minus A squared B. Okay, adding the exponents, and you still have the B. A times B squared is just AB squared. So we took A times everything. Now we'll take B times everything. B times A, it's going to be a positive because you have a positive. We're going to go ahead and put them in alphabetical. When we write them as a multiplication, we'll put the A squared first and the B second. B times a minus AB is a minus AB squared. Because B, you add the exponents, and then you still have the A. And then we'll take B times B squared, positive B cubed. So all we did was multiply, and now we'll simplify. Combining like terms. I have an A cubed, and there are no other A cubes. So we write down A cubed. We have a minus A squared B, and it looks like we have a positive A squared B. This one and this one. Those two are like, and so when we combine the coefficients in front, we get 0. A minus 1 and a positive 1 is 0. Then we go to this term, AB squared, and a negative AB squared add up to 0. Alrighty. And then we just have the plus B cubed. Okay. So we end up with this right here. Well, looking, if I wanted to go backwards, if I were given something like this, and I wanted to factor it, okay, this, I now have a formula to follow if I know what the A and B are. Okay, so here, this right here, if you wanted to factor something that looks like this, the sum of two cubes, going back to this one, the sum of two cubes, you could follow the formula, which is what we're going to practice. Likewise, if we were to multiply this, A times all of those, minus B times that, and then combine our like terms, we end up with A cubed minus B cubed when I do that. So now we have a formula to follow. So if your polynomial looks like this and you want to factor it, you can just follow this right here, knowing what the A and B are. Okay, so let's go ahead and look. So given, we just rewrote it. Here, given the sum of two cubes, you can follow this formula to break it into parts to work with it. The difference of two cubes, you can follow this formula here in order to factor it. So these are the only ones. I remember we kind of talked about the a trinomial, a perfect squared trinomial, and you can follow formulas. You don't have to, but here you'll need to memorize those, for your next class. Obviously, you can use your notes on this test, but for your next class, you would need to have those memorized. How are some things that you can do to memorize? Well, if you look, they're really basically the same. All right. But what's different is some of them have addition and some have subtraction. So if you look at this first one, notice that they match when you first write them. So they both have an A plus B, or they have an A and a B in the first parentheses. One's a positive and one's a negative, and notice that they match whatever the original is. Then over here, I have, again, a minus sign and a plus sign. So what you can think of it as is you only have one subtraction in each of these formulas. So if you don't have it here, you'll have your subtraction here. If the subtraction is matching in the original, then you're done with subtractions. Okay, just kind of some little hints on how to maybe memorize those. Now, another thing that could help is that we need to know the cube of numbers. And chances are, we probably won't use those. But, 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So knowing if these are in the original, if this bottom row is in the original, what did you cube to get this? Well, you cubed a 6. This is something a lot of people may not realize, what three numbers multiplied together give you 216. These are common ones. And so these are ones just to make things quicker. It might be nice to know these, especially up to the 5. All right, you're going to see these quite a bit. Not so much the 6, but it'll come up. So what we're going to do is we're going to practice using the formulas. So here, first off, looking at this, it's the sum of two cubes. So this right here fits our form. This right here. Because whenever you have that cubed or a sixth, we'll talk about that. You can start with this here. Now, A is what you're cubing to get this, and the B is what you're cubing to get 27. when we follow our formula. So here I've got a cubed. I'm going to write the formula down. A plus b matches. You square the a, then you multiply the a and the b, and then you square the b. And I do have one negative in the whole formula, and that's with the ab. So following this, the a, what are you cubing to get an x? Well, x times x times x gives you x cubed. So the a in the formula is x. You're cubing the x to get this. What three numbers are you multiplying to get 27? 3. 3 times 3 is 9 times 3 is 27. So in your formula, the b is a 3. And that's pretty much the hardest part. Now you fill it in. So you'll go x plus 3. Then you square the x. You multiply the a and the b together. And then you square the b. And we're done. That's all you have to do. Let's try another one. This is a, and then always look for the greatest common factor, which I forgot to mention here. Is there something I can pull out before I start the factoring process? No, there's not. So now this is a difference of 2 cubes. So we'll have, I'll just write the minus b cubed. The formula is a little different. It's a minus b, okay? It matches. So then you square the a, you multiply them together, the a and the b, and then you square the b. And again, you only have one subtraction in the entire formula for both of those. There's always only one subtraction. All righty, let's figure out, what am I cubing to get the first term? What does a equal in the formula? What am I cubing? Well, you're cubing a y. So in our formula over here, a's, all the a's are y's. What are you cubing to get 125? Well, that's a 5. So all our b's are a 5 in that formula. So now we just follow it. We take our a, which is y, minus 5. Then we square the a. Then we multiply them. And then we square the b. And you're done factoring. So probably, I guess maybe the hard part when you get into the 1400, those of you taking it, is just trying to remember the formulas. And that it is factorable when you get to something, a sum of 2 cubes and a difference of 2 cubes. All right, I do want to keep practicing this idea. So, well, I think there's probably enough room to do these on your note sheets. I want to straighten this out just a bit. Sorry about that. There. Still in focus? Yes. Okay, look for the greatest common factor. And again, there's nothing that can be taken out of these. So what we'll do is we'll just figure out, we have a difference here. I can go ahead and write that down. A cubed minus b cubed is a, oh, I should put an equal sign in there, equals a minus b, a squared plus, you multiply them together, plus you square the b. Okay, so there's our formula. Now let's determine what the a and b are. Well, what am I cubing to get this first term? Well, I'm cubing a 5. Okay, we talked about in the last one. Well, I'll just put it over here. A equals 5 and an x. If you were to take 5x times 5x times 5x, you're going to get this right here. So you had to, what do I cube to get this? What do I cube to get this? So there's my a. And that might be kind of tricky when we do the a squared, but you guys can get it. What am I cubing to get y cubed? I'm cubing a y. Y times y times y. And this is 5x times 5x, if you can read that. All righty. So now that we've determined what we're cubing to get the first term, what we're cubing to get the second term, we'll follow the formula. So we start with our a, which is 5x, minus our b. Now we're going to square the a. When you square that, you have to square the 5. So this squared is 25x squared. So you square the 5 and the x. Plus, multiply them together, 5xy, plus b squared, y squared. And now you're done factoring. I don't know, to me, these are sometimes easier than doing the guess and check method or the Xbox method. So, all right, let's try another one. This is also a difference. Now, looking at it, you don't know, is it going to be a difference of 2 squares, or is it a difference of 2 cubes, or maybe nothing at all, and we're done? Well, we're going to pull out the greatest common factor first to determine. So you always need to do that first. Well, 2 is the largest number that goes into both of those. All right, so, you can always try 2, and then you could try dividing them both by 4, and you'll get, this will be a decimal. You could divide them by 8, so, but ultimately 2 is the largest number that goes into those. They look like they both have a y, and the smallest will use the y to the first. Okay. This divided by 2, 128 divided by 2 is 64. Y to the 6th. Okay. Minus, I'm not sure how I want to do this. Minus 250 divided by 2 is 125. X to the 6th. Okay. We're going to look at another one. I was just thinking about another one we're going to look at is D, that has both these 6th powers, and it's going to be done differently. You could use a difference of 2 squares, but you can't, because something times itself doesn't give you the 125. If something times itself gave you the 125, for this right here, I would have used the a squared minus b squared idea. And so we're going to talk about that when we get to D. And you may have one of these on your homework, but. All right, so what we'll do is, this is a difference of 2 cubes. It's not a difference of 2 squares, because y to the 3rd times y to the 3rd, and 8 times 8. So it fits that, x to the 3rd, x to the 3rd, but nothing squared gives you that, other than with a radical. So we'll do cubes. So we've got our 2y. Well, let's see, what is A? A is going to be, what are you cubing to get 64? Well, you can go back to the chart on the previous page, and you'll know that it's 4. 4 times 4 times 4 gives you 64. What gives you y to the 6th? Well, just divide that by 3 and you get y squared. So if you were to take 4y times 4y times 4y squared, y squared, y squared. If you were to multiply those together, you'll get 64y to the 6th. So if you just divide that by 3, and that'll tell you what you're cubing. And then you can always check it just to make sure. Now, what's the b in our formula? The b, what are we cubing to get 125? Well, on your chart, it tells you 5. What are we cubing? Take 6 divided by 3, and that gives you a 2. So we have x squared. So if I were to take 5x squared, Okay. To get the 2, I just divided by 3. I need 3 of them. Okay. And you could check it. 125, add exponents, you get a 6. All righty. So knowing that, we're going to go ahead and fill in our formula. A cubed minus B cubed. A minus B. A squared plus AB plus B squared. So we have A, 4y squared minus our B. Now we're going to square the A. That gives us 16 y to the 4th. Okay. When I square my, just a smidge. When I square the, this right here, when you square it, I'm going to probably come over here. We've got lots of room. You're squaring them both. So then you square that and get 16. A power to a power, you multiply. So we get this. Plus AB, multiply them together. You'll get 20 x squared, y squared, just putting them in alphabetical order. I'm going to run out of room. Okay. Right. Plus, I just add a sheet of paper over there. Sorry, I didn't need to move it over. So I just multiplied them together. That's what this means. You get 20 x squared, y squared plus b squared. Well, how do you square that? Just like we did the A. You get 25. 5 times 5 is 25. And then you multiply a power to a power, x to the 4th. And now you're done factoring. All righty. Okay, let's try another one. Let's keep going. B to the 6th plus 64. Is there something in common to pull out like the last one? Pulled out a 2y. Nope, there's not. So you have a sum. So unless it's a sum of 2 cubes, if it's not, you're done. All right. What 3 things am I multiplying by to get this term? Let's see if it is a sum of 2 cubes. Divide that by 3 and you get m squared. So that must mean that m squared, if I multiply 3 of those together, I get this. Okay, you add exponents, sure. So it looks like our A is m squared in our formula. The B, leave it up slightly, so just give it a second. The B then is what am I multiplying together? If you need to, you can look at the chart. Well, what if you don't have the chart or the number's not on the chart? Well, on your calculator, everybody's calculator is different. Sometimes you have an X key here, something that looks like this. Well, you could put a 3 there, depending on your calculator, how you do that. The cube root. The cube root tells you what you're multiplying together 4 times or 3 times to get that number. That tells you how many you need for this number here. So you can kind of look for that. There are other ways, but we'll just stick with this one right here. Some of you may actually have a cube root key in your calculator. You can look for it. But that tells you the 3 numbers you multiply together to get the one inside. Or hopefully just use the chart. So B, for trial and error, try multiplying 3 numbers together until you get it. B, 4 times 4 times 4. So let's follow our formula. A cubed plus B cubed. A plus B, you match the sign. And now we have A squared. We know we have to have 1 negative, and there it is. The last term is always positive. Okay, A, m squared. plus b, 4. We square that. When we square it, okay, what we're doing is, I'm kind of running into my other one, but m squared squared, you multiply a power to a power, m to the 4th. A times b, 4m squared when you multiply them together. B squared, 4 squared is 16. And you're done factoring. All righty. Okay, let's look at the next one. The next one, it could be a difference of 2 cubes. But in order to get all the factoring necessary, you use a difference of 2 squares first. So we're going to follow the a squared minus b squared. To do that, I'm going to turn it into 2 parentheses. Okay. And I know that divide this by 2, because I just want a 2 of these, you get r cubed. R cubed times r cubed gives you r to the 6th. Then divide that by 2 now, you get minus and a plus s cubed, right? So you start out with a difference of 2 squares. And I think that on the homework, they tell you, hint. Now, the difference between this one and this one is that the 125 could not be broken down into something times itself. It wasn't a squared. There's not a square that would give you that. So if you can use this idea, a difference of 2 squares to start out with, do that. Now we use our formulas for both of these separately. So we finish the factoring. So we've got A is R here. B is an S, that's what you're cubing. And you follow your formula, which is right up here, just to kind of save some time. It's right up here. We take A minus B. Then we square the A. Then we multiply them. And then we square the B. So this is this right here. Times, and we're going to use the cube, the sum of 2 cubes, which is right here for this one, where A is R and B is S. That's what you're cubing to get those. I don't know, even if I write small. So you take R plus S times R squared minus, multiply them, and then plus square the B. And that's that factored. Now you're done. Alrighty, so it's really not too bad. What we're now going to do is look at solving with this idea. And this it's actually isn't too bad. First off, set it equal to 0. So I'm going to bring this over. So that's our first step on all of these. Keeping the first term positive. If that had been a negative, I would have brought it to the other side to make it positive. All right. Now, I guess maybe the hard part is recognizing it, that it's a difference of 2 cubes, which it is. So we're going to x times x times x gives you that. So A is x. 6 times 6 times 6 gives you that. So our B is a 6. Let's follow our formula, a difference of 2 cubes. we go A minus B, then we square the A. You've already got your negative, so then we multiply the A and the B, and then we square the B. Let's follow that using these right here. A is X, B is 6, and then we square the A. Then we multiply together 6X, and then we square the B. All right, now you're asking yourself, I've never, in all the problems we've been doing, I've never further factored this. And that's because you can't. All right, it doesn't mean it can't be solved. It can be, but it cannot be factored, which makes it kind of nice that you don't have to worry about factoring this second part in order to solve it. All right, so all you have to do, so this will not be 0. Okay, but just this is the only part you have to, because we want to know when is this 0. This is the only number we will set equal to 0, not this one. We'll do some solving of this in later chapters, but just not right now, to see what would the solution be here. But for now, it's just this right here. So then you get add 6. Okay. Oh, sorry. So you get X equals 6. All righty. So the solution is not going to be found here. You know, later we will. A lot of times they're going to end up being imaginary. So here, this right here, you just solve it. Okay. Great. Just solve that first one when you're solving it. All right, let's do another one. Righty. Looking at this one again. All right, so again, we'll set it equal to 0. Here, which it already is. Then we look for the greatest common factor, and there's not something that goes into 64 and 27 both. The 27 doesn't have a variable. So we recognize that it's a sum of 2 cubes. So we have A cubed plus B cubed. So we match the sign. Then we square the A. We have a negative, multiply them. And then we square the B. And then we'll set it equal to 0. Okay, here, what is the A and what is the B? Well, A, what times what times what gives you 64, and that's 4. What gives you X cubed? 3 divided by 3 is 1. Okay, so 4X times 4X times 4X is 64X cubed. B. What cubed gives you 27? And that's a 3. So 3 times 3 times 3 is 27. Now, let's fill in our formula. We've got 4X plus 3. You square that, and you're going to get 16X squared. And you square that, square the 4 and the X, minus, multiply the A and the B together, so you get 12X. And then plus B squared, which is 9. So the only one that will be 0 will be this first one right here. Okay. We're going to look at solving this and what the solutions look like and why for this one later. But otherwise, we're just going to look at. Okay, I had to quit there for a second. So anyways, going back to this, so we factored it. The only one you worry about when you're solving this is this first one right here. That's the only one that will be 0 there. Okay, so then you just solve that. And divide by 4. We're going to talk about this in a later chapter. So, all right, perfect. So there is your solution to this. Okay, you break it down using the formula, and then you set your first parentheses equal to 0, and you're done. All right, so what we're going to do is we're going to review all of our processes now. Okay, so here in solving. And we're going to do a few of these just to practice, especially if you're struggling. Maybe this will help some. Okay, looking at this to solve it, we set it equal to 0. So I'm going to do that. So we end up with 8t squared minus 14t equals 0. First step, got to set it equal to 0. Next step, greatest common factor. And in this case, 2 goes into both of those. And t to the first, you use the smaller exponent. Okay. Now, again, make sure that it's the largest number that goes into both 8 and 14, those coefficients that you pull out. Sometimes you may have to go back and say, oh, there's a larger number. Okay, take this divided by this, and you'll get 4. 8 divided by 2 is 4. T, subtract exponents, t to the first. Multiply it to check it, and yes, you come back to the original. Negative 14 divided by 2, let's see, we've got a minus 7, and the t's cancel. Multiply, come back to the original. Now you ask yourself, what's inside? Can that be factored anymore? It is a difference, but not of squares or cubes. Those are just a single. So you're done. You are done factoring by just taking out the greatest common factor. Can't break it down anymore, which means we'll either have this will be 0. I use the 2 equals 0. Or this will be 0. One of these numbers needs to be 0. Divide by 2, 0. So when you got that variable out there, you'll always have 0 as one of your solutions. In other words, it'll cross the x-axis at 0 if you were to graph this, or the t-axis. Add 7 to both sides. Divide by 4. T equals 7/4. Okay. So t is equal to 7/4. Yeah, or yeah. Okay. Then you're done. So you have 2 answers. Let me write those down. Right there, 0 and 7/4. Those again are the zeros, the roots, the solution. If these were x's, we could, in graphing it, it would be the x-intercepts. All righty. Let's go to another one. Again, first step, set it equal to 0. So we have x squared minus 20x plus 100. Okay. No like terms, so they're all 3 separate. Ask yourself if there's a greatest common factor. There is not. Okay, you just have a 1, a 20, and a 100. No common variable. Okay, now this goes back to the perfect square trinomial. We're going to try that. And the reason I'm going to use that is because I know 10 times 10 gives me this, and 10 plus 10 gives me this. So it'll probably be 10 times 10 gives me 100. I want a positive, so the signs match, and they're both negative. Okay. Let's double check, make sure we get the middle term. So we've got last times the last is that. So here we've got the outside minus 10x, the inside gives me a minus 20x, so it works. Now, these two match. So when you're solving it, you just need to use one of them. You don't need to use them both. If they ask you to factor, you would rewrite it like that, but we're solving, so we don't really need to do this. We just need to pick one of these, set it equal to 0, and solve it. So there's only one spot. It's going to actually touch the x-axis at 10. So we have 1, 0, that's 10. We have one solution, that's 10. We have one root, 10, and one x-intercept, 10. Okay, let's look at another one. I can just put this underneath here. Hoping you're catching on. Okay, when you have 4 terms, we're going to use grouping. And you can't combine those 4 terms. Obviously, it's already been set equal to 0. So, and you can't, there's nothing you can pull out of all of them that's in common. So we'll go ahead and we're going to group. The only problem is when you group this negative outside, it changes that sign. So in your final answer, you'll have a negative there. If that were a plus, you don't change the sign. You just group them. So here we've got x cubed, and you do this when you have the 4 terms. Oh, forgot the x, but I'll stick it in there. Okay. Now within these groups, you pull out what's in common. Here, x squared. Okay, there's not a coefficient, but there is, again, they both have x's and you use the smaller one. This divided by this is x, multiply, goes back. This divided by this is 5, multiply, it goes back. So this is how you do 4 terms. Minus. Okay, we're going to pull out a 16 here. We've got 16, 16x divided by 16 is x. 80 divided by 16 is going to be a minus 5. Chances are they got a match. So if you were to multiply this one out, you come back to the original with a positive 80 at the top. Now here, we're going to pull out what's in common between this group and this group. That's an x minus 5. If I take this out of here, I'm just left with an x squared. If I take this out of here, I'm left with just a minus 16. This can be factored. It's a difference of 2 squares. So we have x minus 5. X times x gives you x squared. 4 times 4 gives you 16 minus plus, because there's no middle term, so it's got to drop out. Minus 4x and a positive 4x is 0. So again, finish your factoring. Equals 0. All right. Well, you've got 3 numbers that you're multiplying. This represents a number, a number. One of those has to be 0. X minus 5 equals 0. X minus 4 could equal 0, or x plus 4 could equal 0. Those are your 3. Oh, let me scoot it over a bit. Those are your 3 possibilities once you've factored. Let's see, add 5. And we've got x equals 5 as a solution. It'll cross your x-axis at 5, this graph would. Add 4. It would cross your x-axis at 4, minus 4. It would cross your x-axis at a minus 4. Those are your 3 solutions. Crosses the x's 3 times. Notice this, and the highest and the degree of your polynomial. Let's review a second. The degree of the polynomial is the highest exponent here, right here, unless it's two variables, then you add them together, but these don't. So that tells you the highest number of solutions you can have. You're not guaranteed 3, but you can't have more than 3. This one, the degree is 2, so I can have 2 solutions, but I may have 1. You just can't have more than the degree for the solutions. I'm going back to the top one. The degree is 2. That's our highest power, so I know I could have 2 or less. And I have 2, but no more. That tells you the maximum number of solutions, the degree of the polynomial. All right, let's see if, oh, we have some more to practice. This will be good. Just in case some of you are struggling, the more examples you see, the better off you might be. Okay. All right, set it equal to 0 and put them in the right order. So when I bring that 17 over, I'm going to put it in the middle between the two. So I'm going to add 17x. So that gives me 2x squared plus 17x plus 21 equals 0. Now, look for the greatest common factor. There isn't one because there's not a number that goes into 2, 17, and 21. And they don't have a common variable. So now you need a factor. Well, you have a choice. I mean, you could use the guess and check, or you could use the X box method. Let's go ahead. We'll use the guess and check just because there's only one combination here. And there really aren't very many combinations here, 21. So there aren't too many things that we have to try and see in those spots. And then what we can do is on maybe this one, we'll do the X box as a review of the X box. All right. So we only have a choice of 2x and x. That's it. 2x times x gives you 2x squared. No other choice. Now you have a choice. You've got, for the 21, the last spot, you can either put 3 and 7, or you can put 21 and 1. Let's do 3 and 7. Just guess. And we know they're all positive. I'm just guessing. If it doesn't work, I'm going to swap the 7 and the 3. And then if that doesn't work, you'd have to go to the 21 and 1 in that spot, in the last spot. So let's check. Wow, I think we got it right. 14x and 3x, these give you 17x. So it worked the first time. Otherwise, I would have swapped these two and checked to see if I get a 17x. All right, so knowing that, we have 2 solutions. Either the first parentheses is 0, or the second parenthesis is 0. And you solve them. Divide by 2. Oops, negative. Negative 7 halves. Not too bad. And then the other one, x equals a -7. So your 2 solutions are a -7 and a -7 halves for that solution. All righty, let's go to the next. Let's go to E. Now looking at E, it's already set equal to 0. So you have to ask yourself, okay, is there a greatest common factor? Well, no, not with all 3 numbers, the 12 and 3, but not with that 20. There's not a number that goes into all of those evenly. So we're going to start to factor. And this one, we're going to use the X box method as a review for that. Yeah, here. My paper's right here. So we're going to use the X box method. All right, so we multiply those two together and get 36. And 20 goes down here. So you start, making a list of numbers that multiplied together give you 36. And then we're going to keep going down the list until when we add those numbers, we get a 20. So we're going to take like 1 times 36. We're going to multiply. Is that showing up yet? And then we're going to add the digits here. We're going to add these numbers and see what we get. And we want a 36 and a 20. So we do get 36. But when we add, we get 37. And we do want a positive 36. We want a positive 20 when we add them. Okay, so now let's do 2 as our next number. Take 36 divided by 2. Yes, we get 18. So when we multiply them, we get 36. 2 plus 18 is 20, which is what we wanted. So it looks like we're done. We don't have to go to the 3 times and then take 36 divided by 3, you get 12. 3 times 12, 4 and 9. So if 5 doesn't, you'd skip 5 and go to 6 and 6. All right, but we found it. So now how do we set this up? Well, with your parentheses, you go 12m and 12m. So those were going to kind of match this first term here. And it doesn't, here, let me put the 2 in the 18 here, in those spots. Doesn't matter which one has the 2, obviously. So we'll go plus 2 and plus 18. And you reduce them. Does something go into these? You're going to reduce these 2. Well, you can divide them both by 2. So I divide by 2, divide by 2. Oops, excuse me. I put the answer there. 6m plus 1. There's your first parenthesis. So you reduce it down. And then the other one, what goes into 12 and 18? The highest number would be a 6. So divide by 6. 2m plus 3. And there's your factor. You could check it. The first times the first is 12m squared. And then you've got 2m and 2m and 18m is 20m. The last times the last equals 0. So to solve this, you go 6m plus 1 equals 0. Subtract 1. 6m equals a negative 1. Divide by 6. M is a negative 1/6. Oh, sorry about that. So again, you just subtract 1 and then divide by 6. So there's one solution. Remember, the maximum we can have is 2. The other one, the other parentheses, it represents another number. If that's to be 0, divide by 2, m equals a negative 3/2. So there's your other solution. Okay. All right. So you have the 2 solutions. Any questions on that? All right. Let's go ahead and look at the next one. That's a negative. It's kind of hard to see. Now this one's set equal to 0, but it's not rearranged right. So I'm going to rearrange it. It was already set equal to 0. Greatest common factor. Well, since they end in 0 and 5, I know that 5 will go into all of those evenly. So we'll go ahead and divide them by 5. We may discover, we may look at it and say, wow, there's another number. So we'll just go ahead and divide by 5. And the 20 doesn't have an x, so it's just 5. So we have 9x squared dividing. So if you multiply, you come back to the original, plus, that looks like 20 divided by, or 60 divided by 5 comes out to be 12. Okay. 5 times 12 is 60. And then 20 divided by 5 comes out to be 4. Now, I'm not going to use the Xbox method. What I think I'm going to try first is I know that something times itself gives me this, and something times itself gives me this. So I'm going to see if it's a perfect square trinomial before I use the Xbox method. Sorry about that. So here, we've got, I know that 3x times 3x gives me 9x squared. 2 times 2 gives me 4. And everything's positive. Do you get the 12x? Well, 6x and 6x is 12x. So it does work. All right, so when you're solving this, if you look at that 5, there's not a variable. So it has nothing to do with the solving. You don't have an x equals 0 because there's no variable. So you pretty much ignore it. Now here, because these match, you only need to do one of them to solve it. Subtract 2. Okay. Then divide by 3. Okay. X equals a negative 2/3 is your only solution. We knew the maximum we could have is 2, but you could have 1 or none. Okay, perfect. Last one, then we're done. There's again, it's set equal to 0. The greatest common factor, there is not one, but this looks like a difference of 2 squares. So 3y and 3y give you 9y squared. 5 times 5 gives you 25, plus or minus, so you have no middle term. Positive 15 and a negative 15y is 0. Okay, so now you set both of those equal to 0 and see what you have. So we have 3y. Either the first number will be 0 or the second number will be 0. And you solve it. Subtract 5. Y equals a negative 5/3 when you divide by 3. And the last one, you add 5. Divide by 3, positive 5/3. And those are your 2 solutions. So again, I knew the maximum I could have was 2. And I've got a negative 5/3 and a positive 5/3. Now, if you were to put this in here and square it, make sure again with the negative, use parentheses. Square it times 9, subtract 25, you'll get 0. All righty. Well, that covers that section. We just have one more to go before we're ready for the test for chapters 5 and 6. If you have any questions, I encourage you to let me know so we can work on them. All right. Bye-bye.